We are going to be talking about ellipses today. What I'd like you to have into your journal is this. This picture right here. All right, we have two axes in an ellipse. We have what's called the major axis. So the major axis goes all the way across the ellipse. The minor axis also goes all the way across. What I'd like you to put into your journal is the ellipse formula, okay? But you need to understand it kind of depends on which way we're going. But right now, I'd like you guys to write the formula for an ellipse. So I'm going to scroll over here. I'm going to take the hand here, just drag it, click on it, come on, click on it. Right over here. We're going to take a look at this, and we're going to write this down in our journal. And you're like, what? And I'm going to pause the video because my students actually need to have an opportunity to write this down. Make sure you take the time and energy to write these down, because if your ellipse runs really long with the x's, you're going to lead out with the x and it's going to be over a squared. Whereas if it stretches out more vertically, you're going to lead out with the y squared. That's going to be the important part of the discussion. Okay, so right now let's go over here. Let's take a look at, we have what's called the major axis and we have what's called the minor axis. Let me go back right over here. What I want you guys to do is I want you guys to write the major axis. This is something that's not on your little chart here. The major axis is always equal to 2 times a, where the minor axis is always equal to 2 times b. All right? So what we're going to do is we're going to use a Khan Academy example of a problem, and we're going to label all the parts for one of the ellipses. So we're going to look at the Khan Academy. So I'm just going to go over here to the Khan Academy, and we're going to take a look at this, and we're going to make a picture that goes with it. Okay? So right now, what I'd like you to do in your journal is we're just going to write down this one problem, and we're going to actually make a graph of it. It's not going to be a perfect graph, but it's going to be a graphical representation. All right. So what I'd like you guys to do right now is we need to find what's called the center of the ellipse. All right. Now the center of the ellipse is going to be what's called the h and the k value, but it's going to be the x value and the y value of the ellipse. All right. So right now, what is going to be our center? It's got to be at a 5 and a negative 8. So what I'd like you guys to do is the center of your ellipse will be at a 5 and a negative 8 for this equation. Okay? Now, what do you guys think it's going to look like? Do you think it's going to look more long horizontally or vertically? Which means if I find my ellipse here, change colors. There we go. Is it going to look more like this, or is it going to look more like that? The first one? Let's look. Okay. What I'd like you guys to do is I'd like you guys to go to regular Desmos. Okay, just go to regular Desmos. Now, if you're in regular Desmos, what I'd like us to do is I'd like us to type in our equation exactly as it appears. It says x minus 5 squared over 25. So I'll put a little division bar. Nope, there we go. X minus 5 squared over 25. Okay, put plus, make another division bar, parentheses, y minus, oh sorry, was it y plus y plus 8, okay, squared over 81, okay, equals 1. Oh, look at there. There we have our ellipse. Okay. So if you would please, in your journal, could you guys make an ellipse that looks like this? Just draw one real quick, and we're going to label the different pieces of it. Okay. Now, understand this, guys, is actually the a squared, and this part's actually the b squared. So they didn't put it in order. They put the x and the y in order, but technically you could also write it this way. I wish you wouldn't do that. There we go. Okay. So either way, it works. Understand, whichever number's the biggest will be your a squared. So what is our a value? Our a value is 9, and our b value is 5. Okay? Well, let me do it. No, hold on right there. Oh, well, won't let me do that. What I'd like you to do now is in your picture, please. This is going to be important for your journal. I want you guys to draw in your major axis and draw in your minor axis. So just draw them in, because I want you guys to see how you can find different pieces of an ellipse. Does everybody see how this distance right here is 9 units, and that's also 9 units? This is 5, and that's 5. So what is the length of our major axis? The length of our major axis is 18, but the length of our minor axis is 10. So remember when I said the major axis is always equal to 2a and the minor axis is always equal to 2 times b? That's what I wanted you guys to be able to have into your journal. All right? So right now we have a major axis and we have a minor axis. So we're going to use a little formula to help us find our foci. So put c squared equals a squared minus b squared. So c squared is going to equal, our a squared is 81. Our b squared is 25. So our c squared will equal 81 minus 25, which gives us 56. So what does that mean our c value is equal to? Plus or minus the square root of 56. But 56 breaks down to, I believe, a 4 and a 14, and that breaks down to a 2 and a 2. So that's 2 radical 14. All right, that's 2 radical 14. So right here, if I did the square root of 56 and I did 2 radical 14, I want you to see they're the same equivalent number. Now let me explain to you why you need this c value. So let me go back over here to this. Does everybody see how the foci right here, it says h comma k plus or minus your c value? So if everybody would please, let's write down what h and k are. All right. So our foci for this one is going to be h comma k plus or minus my c value. So what's my h value? That's this point right here. And what was the center of our ellipse? What did we say the center was for our ellipse? 5, -8. Very good. So our foci is 5, comma, -8 plus or minus 2 radical 14. That's where our foci are. We're going to plot them. We're going to estimate where they are. Okay? So could you guys help me right here? And we're going to do -8 plus 2 radical 14. So right now, what I'd like you to do, just in the calculator, -8 plus 2 radical 14. And we get what? Basically -1/2. So here's what I want you to do on your paper. I'm going to put it in purple for this lavender. Right there. Right there is one of my foci. Okay? I'm going to call that F1. F1 is at 5, comma, -8 plus 2 radical 14, or a negative half, pretty close to a -1/2. That's focus number one. Sorry, that's focus number one. That's one of the foci. The other one you can kind of count, right? That goes right here. The other one's going to be right about there. So how do we find the other one? You can just do -8 minus 2 radical, where is it? There it is. Which puts us downward, basically -15.5. So -15.5 is right about there. So we're at 5, comma, -8 minus 2 radical 14, which is at that -15.5. I don't know why that disappeared. Call that focus 1, and I'll call this focus number 2. Together they're called foci. Okay? Focus number 1, focus number 2. Here's what makes an ellipse special. If I take any point on the ellipse, I'm just take a random point right there. I want you guys to understand that from that point, you don't have to do this, you don't have to draw this on your paper, okay? All right? But if I take from that point and I go to the foci, if I take any other point on the ellipse, just some random point, these distances, the actual distances, will be the exact same as the sum of these distances right here. Okay? So if I call this distance A, and that's distance B, and that's distance C, and that's distance D, you could say A plus B would equal C plus D. Even if they weren't all the exact same A's, I'm not saying A equals C, but the sums would be equal to each other no matter what. That's the definition of an ellipse. I'll kind of take all those off because you don't need to have all that junk on in your journal. Okay? And I'll take that one off right there. There we go. Now, on the Khan Academy, what are they going to be asking you to find? All right? Well, what's its center? What is its center for this one? 5, -8. So we would just type in a 5 and a -8. Now it says, what is its major radius? Not major axis. Okay? So its major, I'm going to say, is 9. Now what's the distance of the whole thing? 18, but the major radius would be 9. What's its minor radius? 5. Now the minor, hold on a second. What word am I trying to find here? Oh, the minor axis would be a total of 10. Okay? But the minor radius would be 5. Okay? So right now, what would be the center of this guy right here? 9 and -2, right? 9, -2. Which is bigger? This one's bigger, right? So the major axis would be a total of 16 units, but its radius is only what? 8. Correct. You're just taking the square root of this. That's all you're doing. All right? And its minor axis is 5. So obviously these are not going to be difficult problems. Why do we do all this work? Because there might be questions about the foci later. What's the center of this guy? -7, -5. And what's its major radius? It's going to be 4. And its minor is just going to be 2. Okay? So that's all you're doing for those. Up here, we are going to be interpreting what's happening. Okay? So here we're just actually looking for the graph. So what's going to be the center of our ellipse at a 3 and a +6? But it's going to be, what's going to be the length of the major radius? 5 units, and that's going to be 4 units. It's looking pretty good here. Hold on. We got a 3 and a 6. All right, it goes up 1, 2, 3, 4, 5, and 1, 2, 3, 4. It looks like A. Yeah. All right, so now we have this one. So now we actually have to build the equation. So this is the last one I'm going to do for today. All right. So right now I'm going to call this B. I'm going to call that A. This is B. This is A. What's our center? What's our H and our K value? We're at a 2 and a what? 2 and a 1. Bless you. All right. Now our A value is equal to 1, 2, 3, 4, 5, 6. So our A value is 6. So we know A squared will equal 36. Our B value is 1, 2, 3, 4. So our B value is 4. So our B squared value will equal 16. Okay? So right now, even if I wanted to start with the x's, I can. I'm just going to put x minus 2 squared. But what's it going to be over? It's going to be over 16. Remember, it's over b squared. All right? Plus y minus 1 squared over 36 equals 1. Now, how do I know it's going to be this one? Because this is longer. Always put your a squared over whichever. If it looks more vertical, you know you're going to be putting it with the y's. If it looks more horizontal, you're going to be putting it with the x's. So I'm just going to type this in right here and be done. Oh, yes, you have to put equals 1. Yes, that's the formula for the ellipse. So just remember, when you're typing it in, okay, it's going to be x minus h squared. Now, this is either going to be a squared or b squared. I'm just going to put a squared just for the formula. This is going to be y minus k over b squared. And it's always, the sum of them is always equal to a 1. All right, I'm going to type it in now. It's going to take a little bit of time because I got to put the little division. Got to put parentheses x minus 2. This is where you got to take time. And I believe that was over a 16. Got to put a little plus. Y minus 1. Got to square that over a 36. If I counted correctly, 1, 2, 3, 4, 5, 6. Okay. And yes, you must put equals a 1, like that. All right, so that's basically what you're going to be doing today. If you mess up, say see step-by-step solution, and they should give you a picture of the graph and let you know what the a squared and the b squared was. All right, so good luck.